Hi, with math is easy with Ala. Today we will discuss also differential equations, non-exact differential equation. Example 2. How can we solve y plus y to the power 4 dx plus x times y cubed minus 2 dy equal 0? We know that the form of non or the exact equations, it's m, yes, m xy d x plus n xy dy. So this function will be mxy, and the other one it will be nxy. Now let us find the partial m with respect to y. It will be 1 plus 4y cubed. Now partial n with respect to x, it will be x times y cubed minus 2. It will be y cubed minus 2 because the y cubed minus 2 will be constant. Multiply by x, it will be the constant, so it will be y cubed minus 2. We see here that partial m with respect to y is not equal to partial n with respect to x. So it's not exact. So we will go to integrating factor. In this example, we will take ry. We will find ry. Ry, what we will do, 1 over m times partial n with respect to x minus partial m with respect to y. 1 over m, it means 1 over y plus y to the power 4 times partial n over with respect to x, it will be y cubed minus 2 minus partial m over with respect to y, it will be 1 plus 4y cubed. And here 1 over y plus y to the power 4 equal y cubed minus 2, and we will remove the brackets, so we will change the sign inside the brackets. It will be minus 1 minus 4y cubed. Now simplify y plus y to the power 4. Here it will be this one with this one, it will be negative 3y cubed, and minus 2 minus 1, it will be negative 3. So we will take a common factor here, y divided by y, it will be 1 plus y to the power 4 divided by y, it will be y cubed times, we take minus 3 as a common factor, it will be minus 3y cubed divided by minus 3, it will be y cubed. Minus 3 divided minus 3 will be plus 1. We can now simplify by like this, it will be divided, it will be 1 over y times negative 3, it will be negative 3 over 1. So this is the integrating factor. Now, how can we find mu y? Mu y is e to the power the integral of ry dy. It means e to the power integral of minus 3 y dy. So this equal to e ln y to negative to the power negative 3. And this equal to y to the power negative 3. What I did there, it will be like this. Let us explain it more. E to the power integral minus 3 over y dy. Take minus 3 out. It will be e minus 3 integral y dy. Oh, 1 over y. Let's write it here. It's not seen. Okay. E minus 3, I'll take it out. 1 over y dy. So it will be e to the power minus 3 and the integral of 1 over y dy ln y. Take minus 3 by using a logarithm identity. It will be ln y cubed, and this will be y negative, here is negative 3. So it will be minus negative y to the power negative 3. And this is the integrating factor. Now, we will take the equation 1 and multiply all the terms by y to the power negative 3. It will be y to the power negative 3 y times y plus y to the power 4 dx, and y to negative 3 we multiply it by x y to the power 3 minus 2 dy equal 0. Now y to power negative 3 times y, it will be y to power negative 2 plus y to the power negative 3 times y to the power 4, it will be y to the power 1, it means y, plus, now put x out, and y to the power negative 3 times y to the power 3, it will be y to the power 0, and y to the power 0 equal 1. Y to the power negative 3 times negative 2, it will be minus 2 y to the power negative 3 dy equal 0. So take this one here. I want to change the, okay, now this is new mx y, and this is nxy. Now partial m with respect to x, no, I'm sorry, here dx. Partial m with respect to y equal the derivative of y to the power negative 2, it means negative 2 y to the power negative 3, and the derivative of y is 1. Partial n with respect to x, this is a constant multiplied by x, the derivative of x1 times the constant, it will be 1 minus 2y negative 3, and you see here they are same, so it's exact. Now we will take one of them. I will take mxy or nxy as you wish. Let us take nxy. Now partial f over partial x or partial f over partial y, this is nxy. So if I derivative here partial, now x times 1 minus 2 to the power y to the power negative 3. Now what we have here, it will be x1 minus 2y negative 3 dy, negative 3, okay, this is n. So integrate both sides, it will be xy equal the integral of x1 minus times 1 minus 2y to the power minus 3 dy. So the second side, how can we integral x times 1 minus 2 times y to the minus 3 dy? We know that x is a constant. Now, how can we integral y with respect to 1 with respect to y? It will be y minus, and the integral of 2y to the power negative 3, it will be 2y to the negative 2 to the power negative 2 over negative 2 plus a constant, and in this time I will make a constant as a function of x. So if I simplify it, it will be xy plus y to negative power negative 2 plus kx. This is what I want now to make partial derivative with respect to x. Now let's take it, and this one I will take it. Let me write it here again. X times, I think, y plus y to the power negative 2 plus kx. I think like this, yes. Yes. This is fxy. Now, partial f with respect to x equal, this is constant. So it will be y plus y negative to the power negative 2 times the derivative of x, the 1 means 1, plus the derivative of k, it will be k prime lx. And this one equal mxy, which is, now we will return back here. Where is it? Y to the power negative 2 plus y. This is mxy. So y yes, y plus y to the power negative 2 plus k prime x equal y plus y to the power negative 2, means that k prime x equals 0. So if we make integral for both sides, kx equal constant. Now return to these equations. Which one? Here. Yes, here. This one, the last one, which we wrote it here. Now, if xy equal x times y plus y to the power negative 2 plus the value of kx, which is c. So we will substitute c instead of kx, and this is the solution. This is equal also, this is what we have, fxy. So please don't forget to subscribe and subscribe to channel. See you in another example. Thanks a lot.